Welcome to today's episode of our Tech Podcast. I'm thrilled to dive into an exciting open source project that's making waves in the world of computer architecture. Yes, we're talking about XiangShan, a high-performance RISC-V processor project. If you're not familiar with RISC-V, it's an open standard instruction set architecture that's gaining traction in the hardware community. So, let's explore XiangShan and what makes it a standout player in this evolving field. What's interesting about XiangShan is that it embodies a modern development approach, particularly agile methodology. This project celebrates agility not just in coding, but in the entire chip development process. They've released papers outlining how they're using this methodology to boost the speed and efficiency of creating processors. Imagine how revolutionary it is when development timelines can be cut down thanks to structured yet flexible processes. Now, the team behind XiangShan, hailing from the Institute of Computing Technology and Pengcheng Laboratory, has ambitiously included several microarchitecture versions in their pipeline. The first stable version, named Yanqihu, marks the beginning of their journey since June 2020. Following this, they introduced Nanhu and are currently fine-tuning a new version called Kunminghu. Isn't it fascinating how naming conventions often reflect a connection to culture or geography? This holistic approach they've taken with XiangShan has enabled a rich architecture, with the source files meticulously organized in directories like /main/scala for design files, scripts for agile development, and even submodules for floating units and cache management. It's quite intricate. Yet, these organized structures simplify the collaboration and understanding of complex hardware development. One of the great things about XiangShan is its commitment to open source principles. They provide a wealth of documentation, toolsets, and simulation support, all designed to welcome contributions and innovations from the broader community. It's like creating a playground where developers and researchers can experiment, learn, and build upon each other's ideas. As we dig deeper, let's talk about the practical side of things. You can run XiangShan with the Verilator, an open-source Verilog simulator. It's really cool because you can set up an environment and get right into simulation. Think of it like downloading a game and customizing it to your liking. Same idea. Just like with gaming, being able to modify and adapt the code to better understand how it works, or even to debug it, can enhance your experience significantly. Now, if we reflect on the roadmap of XiangShan, it raises an interesting question about the trajectory of RISC-V in the processor market. With companies and universities around the globe keen on using RISC-V to challenge the norms of proprietary architectures, it makes you wonder, could we see a future where RISC-V processors dominate thanks to projects like XiangShan? Before we wrap up, it's important to acknowledge that XiangShan is not just about the technology. It's a testament to the spirit of collaboration, innovation, and the open source community. Each step they take invites others to join the conversation and contribute to the future of computing. So as I leave you today, I encourage you to explore these developments further. Check out their documentation, experiment with their tools, and maybe even dive into the code. Who knows, you might just contribute to the next big innovation in processor technology. Thanks for listening, and until next time, keep exploring the world of technology.